Hello, everyone. I'd like to wish you all a happy holiday. If you go to this website called Checky Day, you can see what holiday it is. Maybe if there's time at the end of this, we'll do that. But we're going to introduce Chapter 5, Section 4. It's dividing polynomials. And I'm going to do something totally different than I usually do. Normally, we'll start off with a definition and a procedure or an algorithm or a step-by-step. But today, what I'd like to do is start off by showing an example of each type of polynomial division. Okay. So it's Chapter 5, Section 4. You might notice in the objectives, that's the goals, the things that by the end of this lesson you should be able to do. You should be able to divide polynomials using long division, and you should be able to divide polynomials using synthetic division. So you might say to yourself, well, Self, I've heard of the word synthetic. It means not real, not genuine, not natural. I use synthetic oil and it costs $13.95 a quart, but it makes my engine last longer. Well, synthetic division doesn't cost $13.95 a quart. Okay? Synthetic division, you're going to love it. You'll see. So anyway, Chapter 5, Section 4, dividing polynomials. And like I said, we're going to start off with an example of each. It might not make much sense, so for the first few, just kind of sit back and watch and see what happens. So this says use polynomial long division to divide this. Now, when we say long division, what we mean is this technique. It's probably been a long time since you've seen that bar, hasn't it? And it's probably been a long time since you did something like this. 62. Let's see how many times that goes into 4,897. By a show of hands, who has it been over 5 years since you've used this? Okay. Yeah, because right, what do? You use a calculator, right? Okay. Well, the steps involved in that are the same as the steps involved in this long division, and we'll get into more detail on that in a minute. So I am going to need that division bar, and this part here is called my what I'm dividing by. It's called the divisor. Okay, and we'll go over all the parts in a little bit. So that's the divisor. The dividend is that which I'm dividing. So this is called the dividend. So there's 4x squared plus 23x minus 16. That's the dividend. And when I divide this, what's going to happen is up on this top line is going to be my quotient. Okay, because that's the answer when you divide. And again, we'll go into more detail with all the names of the parts. So we got the divisor, the dividend, the quotient. And there might be something left at the end. If there's something left at the end, what's that called? It starts with an R and ends with an R. Yeah, good. It's the remainder. So it's weird when we start this polynomial division process, the long division. And again, I'm just going to kind of run quickly through this example. All I'm looking at is this x and this 4x squared. And I want to know how many times will x go into the 4x squared? And it's really unsettling because, to be honest with you, I'm disregarding that plus 5 and I'm disregarding the rest of that for a minute. Not forever, but for a minute. So when I do that, need to get better, faster at switching these pens around. So when I do that, I think I'm going to get 4x. So in that long division process, when you had numbers, what I do at this point is I go ahead and multiply. So I have 4x, but here's where I need to bring this plus 5 back, and here's where I need to bring that other stuff back in. So what I'm going to have is 4x plus 20, x like that. Okay. Does anybody remember the next step in the division process, the long division process? It's kind of weird. What I do now is I subtract. Okay. And here I get 3x, and I have to bring down. I don't know if you remember bringing down, but I have to bring down that negative 16. So again, I'm going to disregard some stuff. Again, I'm going to disregard the plus 5. And again, I'm going to disregard this. I guess I got to bring this to the front. I'm going to disregard that 16. And I want to know now, how many times will x go into 3x? How many times will x go into 3x? X goes into 3x positive 3 times. So what I'm going to do now is multiply again, and this procedure right now might seem kind of foreign to you, but 3 times x is 3x, and 3 times 5 is 15. And again, I subtract, and when I subtract, I get negative 31 as my remainder. Okay, so to this question, the answer, here's the answer. The answer is this: 4x squared plus 23x minus 16 divided by that trinomial divided by the binomial x plus 5 is equal to 4x plus 3 with the remainder, and I'll just say rem for now. Later on we'll do something else with it. The remainder is negative 31. Wow. What do we think? Question. How did I get 20? Okay, the 20 resulted from multiplying, and in a minute we'll summarize like all the steps along the way. But when I took this 4x here and multiplied it by 5, I got this 4x, and then I took 4x and I multiplied it, or 4x times x gave me the 4. Oh shoot, I guess I messed something up there. It's a good thing I'm looking back over this. This should have been a 4x squared here. But the question was, where did the 20 come from? The 20 came from multiplying this 4x here by this 5. That's where the 20x came from. Okay. And the 15 came from the 3 times 5, right? Okay. Where did I get the 4x in the quotient, the first 4x? The first 4x in the quotient comes from saying, okay, how many times does x go into 4x squared? Yeah. So here's the general procedure. I'll just jot this down and we'll come back and revisit this again. Long division involves dividing. So the steps, just to kind of recap what we did, we divide and then we multiply and then we subtract and then we bring down and then we repeat. All that. All of the above. That's basically the gist of long division with polynomials. You divide, you multiply, you subtract, and bring down. That's a lot of work. You'll see why synthetic division is so cool in a minute. And like I said, we'll go back and fill in all the gaps and all the details on these a little bit later. So you divide, you multiply, subtract, and bring down. And then once you've done all that, again, you repeat that process. So you start back at the top and you divide and you multiply and you subtract and you bring down. You might have to do that twice. You might have to do that 3 times. You might have to do that 4 times. It depends on the problem. Okay. So just to kind of show how that relates to this problem, the first thing we did in this particular problem, let me get my magic marker here. We divided 4x squared by x. That was our first division. And then we multiplied 4x by x plus 5, and that's how we got this. So we divided, then we multiplied, and then we subtracted. Make that a little bit bigger. So then we subtracted, and then we had to bring down, and we repeat that procedure over. So let's look at a synthetic division. This one's going to really blow your mind. Okay, but when you get the hang of synthetic division, you're going to love it. Here we go. Synthetic division. People make their boxes different, but I just call that little thing, I just call it a box. I don't know. Don't know what else to call it. But it's weird what I'm going to put in that little notch, if you want to call it a notch or whatever you want to call it. What I'm going to put in there might surprise you. But it goes back to the factor theorem. A while ago, we said if x minus a is a factor, if x minus a is a factor, then a is a 0. So ever since chapter 4, ever since we learned how to solve quadratic equations by factoring, those are a's, not 9's, by the way. If x minus a is a factor, then a is a 0. Ever since chapter 4, we've seen that there's counterintuition in math. A lot of times things are the opposite of what we would think they are. So when I go to put something in this box, you might think, okay, well, I'm going to put a 2 in there. No, I'm not. I'm going to put a negative 2 in there. Okay? One thing to notice about synthetic division, rather than using variables, all I'm going to be doing is just using numbers or coefficients. Okay, so let me just go through and highlight all my coefficients here. There's one there, and literally there's one there. There's a coefficient there, there's a coefficient there, and there's a coefficient there. And that's all I'm going to be using when I go to set this up. And again, if you don't get it the first time through, don't worry, because we'll go over everything in detail here in a minute. So we start with a 1 and a negative 14 and a 51 and a negative 54. And then I'm going to leave a void. I'm going to leave a little bit of space, and I'll go ahead and write that out. Some space. Okay, a lot of people don't want to leave that space there, but you are going to need to leave some space there, some room for this line here. Okay. If you're a bad writer, if your writing goes all over the place and you can't write across a line in a horizontal fashion, in a level fashion, this is going to give you a hard time. If you can't read your own writing, or you write so small that nobody on planet Earth can read your writing, you're going to need to work on that with this synthetic division. Okay. So synthetic division, I always like talking about it because it reminds me of Snoop Dogg. Because the very first thing that I do with synthetic division is I take this very first thing here, this 1, and that arrow didn't do exactly what I wanted it to. Let me see if I can flip it around. There we go. That 1, I just kind of take that 1, and what does Snoop Dogg say when he's pouring Sean John and doing this and doing that? What's Snoop Dogg do? Drops it like it's hot. He drops it like it's hot. So what I'm going to do is I'm going to take that 1 out front, and I'm going to just bring that 1 down like that. Okay? And I drop it like it's hot. Now, before I start doing this, I'll just go over the basics of synthetic division. Bring down just once. All you got to do is bring down 1 time. That's it. Just bring down just once. And then what you're going to do is this. You're going to multiply diagonally, and you're going to add vertically. And then these 2 steps will be repeated. So in both techniques, you're going to be repeating stuff over and over. But with synthetic division, the first time you're going to bring down, and then you'll be multiplying diagonally and adding vertically. What the heck are you talking about? You'll see. And it's not going to make sense the first time. It might not make sense the second time. By the 3rd, 4th, 5th, 6th time, you'll start to get it. Now, before we get into this, let's think back to the long division. Long division, we had to do what? Divide, multiply, subtract, and bring down, right? 4 different things. With this, all we're doing is multiplying and adding after we bring down once. So this is a really, really interesting and fascinating technique. So here I go. When I multiply diagonally, I'm going to get -2, and you might say, well, where's -2 go? Well, you'll see it goes right here. And then I add vertically. In other words, I add right down the column. -14 plus -2 gives me -16. And again, I go back to my horizontal, my diagonal multiplication. -2 times -16 gives me 32. So I'm going to get a 32 over here. And I add vertically. I add down the column. So when I do that, I get 83. And then I multiply diagonally. So when I do that, I get -166. And then I add vertically. And when I do that, I get a 0. And I get a 1, and I carry the 1, so that's -2. So the question is, what numbers am I multiplying diagonally? Diagonally, I multiply this -2 by the 1. And when I do that, that's where this -2 comes from. Okay? And then again, with the multiplication diagonally, -2 times the -16 gives me +32, and that number goes up in that next space there. And again, when I multiply diagonally, I have this -2 multiplied by the 83, and that gives me this -166 there. Okay. The number that's in that little box will always be multiplied by each successive number in the bottom row, right? Yep, yep. So the problem with this technique is it's kind of like going to France. Anybody ever been to France? Anybody ever been to Canada? A little bit further away from the border where they speak French? You go to certain parts of Canada and that's all they speak is French. Niagara Falls doesn't count because there's a lot of travelers. There might be some French speakers there, but you probably see as many French speakers in Michigan as you would at Niagara Falls. Anyway, what happens if you're around somebody that's speaking a foreign language? What do you need so you can understand? A translator. This is the same thing. It needs a translation. It needs an interpretation. So it requires you to say, okay, well, there's numbers here, and what these numbers mean is this. I started with something that was cubic, and then quadratic, and then linear, and then constant. When I divide something, and this goes back to our exponent rules. When I divide something that's cubic by something that's linear, what's going to happen is my exponent is going to be reduced each term by 1 power. So what this means is this is how many x squareds I have, this is how many x's I have, and this is how many constants I have, and this last thing is my remainder. So what we're saying then is our answer is this, that when we take x cubed minus 14x squared plus 51x minus 54, when we take that and we divided it by x plus 2, that these are now the coefficients of my answer. I took a cubic and I divided a cubic by a linear, so my answer, what I'm saying is this. My answer is 1x squared minus 16x plus 83. And again, with the remainder, we'll talk later about how to express the remainder. And the remainder is that thing on the end. The remainder in this case is negative 210. Okay. So what we've got is two entirely different techniques. And you might say to yourself, well, I can see that this synthetic one's going to be faster, so why don't we always use it? And the answer to that question is you can't always use it. Okay? You can't always use synthetic division. The question is, when can you use it? I'll go ahead and write that down. Synthetic division can only be used. Let me say should only be used. Should only be used when the divisor is of the form x plus a for any real number a. So if we look at that divisor, something about it, it's linear. It's linear when we have a linear divisor. Similarly, in addition to it being linear, notice the coefficient right here is 1, right? If the coefficient there isn't 1, you can still synthetically divide, but it gets confusing. It gets very confusing because there's 2 extra steps that can kind of mess with you. So if you're dividing by something then like this, if you divide by x minus 8 or by x plus 7 or by x minus 15, if you're dividing by something like that, use synthetic division. It'll work, and it'll work much faster. Okay. So we've seen an example of each. Probably really haven't gone into much detail about how to do each. So I guess at this point I want to call time out, give a shout out to the future Mr. Minnick because he's such a hardworking man. He deserves a shout out. I'd also like to give a shout out to my first period class. Also like to give a shout out to everyone who took their Chapter 5, Section 3 quiz. If you didn't, you need to see me about that. And I think that's it. Yeah, I know what we've got another shout out, Mason. Nate loves you. So, okay. So let's back that thing up and see what the book says. I'm not the book. I'm not a big fan of using the book, but they're saying long division is one of many methods you can use to divide whole numbers. So what they're doing is they're kind of showing you this is how you divide. So let's just look at a numeric division. A long division, okay? Because this is a skill, let's face it, this is a skill that's handy to have. So let's see how many times, what was that one I started with? Was it 62? And I wrote it down, but did anybody jot down that one I started to write, like 62 divided by something, or something divided by 62? 48 something, like 4897 or something like that? Well, let's do this. 62 into 4,897. So again, with labeling the parts, this part here, well, let me write the problem as it was in the beginning. So if we have this, 4897 divided by 62, the 4897 is what we're dividing. It's called the dividend. It's called the dividend. The 62 is called the divisor. It's what we're dividing by. And usually, we divide something big by something smaller. But not always, but usually that's how we do. So I mentioned before that the steps involved in division are division, multiplication, subtraction, bring down, and then repeat all above. Repeat all of the above. So it's the same thing. It's the same thing, and here's what's weird. We have to put on blinders. We say, okay, how many times does 62 go into 48? Well, it doesn't, does it? So to help us with that, we might say, how many times does 6 go into 48? How many times does 6 go into 48? About 8. Good. So 6 goes into 48 8 times. So that might, so what we're saying there with that is maybe then let's try, we don't know, but let's try an 8 there, right? That's an 8 with a little question mark. That's not a exponent. That's 8. I don't know. 8 might work. It might not. If it doesn't, then I'm going to have to try something else. So that's the division step, right? And then what do? We multiply. 8 times 62. That's going to be 8 times 2 is 16. Carry the 1. 8 times 6 is 48, and we carry the 1, and that's too much. I feel like I'm on The Price is Right. That's too much, right? So 8 didn't work, so what should I try? Got to go with 7, and let's go one smaller, right? So 8 didn't work. We're out of luck. Well, I'm all out of luck, and I'm so lost without. That's bad. So let's try 7. So we multiply. So again, we had to divide. Now we're on the multiplying step. We multiply 7 times 2. That's a 14. Carry the 1. 7 times 6 is 42. Carry the 1. That's 43. So we divided. We multiplied. What do we do now? We subtract. Good. So we subtract, and when we do, 9 minus 4 is 5. 8 minus 3 is also 5. 4 minus 4 is 0 or 0. So we subtracted, and then the next thing is to do what? To bring down. So we got to take that 7 because 62 doesn't go into 55. We bring down the 7. So we bring down the 7. 7 comes down like that. So we bring down. And then what do? We repeat the whole thing again. So let me bring this to the front. So again, we say, okay, how many times does 6 go into 55? 6 times 10 is 60. 6 times 9 is 54. Let's try 9. Let's try 9. Maybe it's 9. I don't know if it's going to be 9. 9 times 2 is 18. Carry the 1. 9 times 6 is 54 with, oh no, that's horrible, isn't it? Oh, coats my goats. What this tells me is I'm going to get 78 point. If it's a decimal, like 78 point, probably 9 something, right? Okay. So, dang it, that makes me so mad that the 9 didn't work. Oh, you have no idea how much that irks me. So let's go back to the drawing board. So 9 didn't work, so let's try the 8. 8 times 2 is 16. Carry the 1 again. And 8 times 6 is 48. Carry the 1, that's 49. So what do we do now? We divided. We multiplied. Now what do we do? Subtract. So again, we're subtracting. So 7 minus 6 is 1. The 5 has to become a 15. And 15 minus 9 is 6. And the 5 here becomes a 4. And then here's where I felt like such a complete lost puppy. You ever see a lost puppy? It's kind of sad, isn't it, when they walk around and they don't know where they're going and they get that little and they don't know where they're at. That's how I felt with division for the longest, up until 6th grade. That's how I felt about division, because I didn't know what to do with the remainder. I really didn't know what to do with the remainder. My teacher said, well, just right next to the quotient, write R7. And I said, where did you get the 7 from? And then she never told me. She never answered me, or maybe she did and I didn't hear her. What's my remainder here? The remainder is 61, okay? So in 6th grade, that's how you would have answered it. 78 or 61, right? Well, I've got news for you. This isn't 6th grade anymore, is it? So here's the thing. If we divide 61 by 62, and to save time, for the sake of time, I'm going to use a calculator to do this, okay? I said it's probably going to be 0.9. I know it's going to be 0.9 something, okay? But let's see what 61 divided by 62 is. Can't use the T99 for that because it'll just give me a fraction again. So 61, I said 61 divided by 62 is 0.98387, blah, 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 blah. Okay, everybody with me so far? Let me take a picture of that. Okay, so 61, I hate when I do that. I do that all the time. I always forget about that. Get that little diagonal line out of here. So 61 divided by 62 is 0.9838. Some of you probably realize this. Some of you might not, though. 4897, I said 4897, divided by 62 equals 78 and some mo, right? Everybody with me on that? Because there's a remainder. The remainder is the and some mo part, right? What does the word and mean in mathematical operations? Addition. It means, okay, so instead of saying and, we're going to add, right? And in 6th grade, we would say a remainder of 61, right? Well, we're not going to say and a remainder of 61. We're going to say plus 61. Anybody know how this is going to work? Out of 62 or divided by 62. Okay? Now, here's the thing. That's a whole number with a mixed, or that's a whole number, I kind of gave it away. It's a whole number with a fraction being added to it, right? With a smaller than one fraction being added to it. Can't we write that as a mixed number then? So that could be written as 78 and 61 60-seconds. Couldn't it? So when we divide on a calculator, 4897 by 62, who can figure out what it's going to be then? It's going to be what? It's going to be how much? 78.98387, right? Everybody see how that works? So 78 plus 61 60-seconds is the same amount. Do we kind of get the idea with the remainder and how that all works? So here's what happens with polynomials then, and it's real important that we figured out that remainder part. And this is the part where you'll want to start taking notes on this polynomial division. Let p of x be a polynomial. Let p of x be a polynomial, and d of x be a polynomial divisor. And q of x be a polynomial quotient. And r of x be a polynomial remainder. I know this all seems really weird, but we're going to be using abstraction here in a second, and that's just how algebra does. It's just so we can cover the general case. P of x is a polynomial, and I probably could have said it's going to be a polynomial dividend because we're going to be dividing it. So we have a polynomial, we're going to divide it by a divisor, we're going to get a quotient, we're going to get a remainder. Here's how this all works. P of x divided by d of x is equal to q of x plus something. Let's see if we can figure out the plus something. It kind of goes back to that last example with the numbers we just looked at. R of x over, nice, good, over, not p of x, d of x, good. Okay. Now, I'm rather disappointed in Math Excel on this point. Okay, Math Excel, would you do this? They're just going to ask you for the quotient. They're going to ask you for the remainder. They're not going to ask you for this format here. If you go on and take pre-calculus, or you take a college algebra class, or the worksheet that we're going to have tomorrow for you to do, you need to be able to, for sake of Common Core content standards and any kind of college algebra class, you need to be able to represent the answer that way. Okay. This is called, it's called some kind of theorem. I think it's called the remainder theorem or the divisor theorem or something. I don't know what it's called, but so you divide a polynomial by a divisor and you get the quotient plus the remainder divided by the divisor. Okay. How's everybody doing so far? Okay. Now tomorrow what we're going to do is we're going to go over the procedures, the algorithms again one more time. Today I want to do one last thing. And it's really cool. And you might say, well, what does this have to do with polynomial division? Well, they're kind of related. Evaluate p of negative 3 for p of x equals 5x to the fourth minus 6x cubed plus 7x squared minus 8x plus 10. Evaluate p of negative 3. Now, what that means, evaluate, if you've forgotten, it means get a numeric answer. And we can see that this polynomial has 5 terms. We're going to have to raise something to the 4th power. We're going to have to cube something. We're going to have to square something. We're going to have to multiply something after we raise it to the 4th power by 5. This is going to take some time and effort, and it's going to be kind of scary, isn't it? So here's how it goes. P of negative 3 is this. It's 5 times negative 3 to the 4th minus 6 times negative 3 cubed plus 7 times negative 3 squared minus 8 times negative 3 plus 10. Wow. So all I did was just made substitutions. I replaced x with negative 3. Now I'm going to do some PEMDAS. Negative 3, the quantity to the 4th, that's 3 squared squared. it's going to be positive, it's going to be 81. So that's going to be 5 times 81. Negative 3, the quantity cubed, is going to be negative 27. So I got minus 6 times negative 27. Negative 3, the quantity squared, is going to be 9. So I get plus 7 times 9. Minus 8 times minus 3, that's going to be plus 24. And then plus 10 on the end. Okay. Notice I haven't used a calculator once. 5 times 80, 5 times 8 is 40. 5 times 80 is going to be 405. 405. Now you might say, well, 6 times 27, you can't do that. Watch me. 6 times 30 minus 3. That's 180 minus 18. That's 162. So that's going to be plus 162, plus 63, plus 34. Okay. No calculator needed so far. 405 and 162 is going to be, it's going to end in a 7. There's a 6 and there's a 5. So that's 567. 63 and 34 is going to be 97. So then 7 and 7 is 14. Carry the 1. That's 16. Carry the 1. That's 664. How we doing? Now what I'm about to show you is going to blow your mind. That's a lot of work, and it required squaring stuff, it required cubing stuff, it required multiplying, and sometimes subtracting and sometimes adding, right? I guess it was always adding, so that kind of worked out in our favor. Watch this. I feel like Vince from Slap Chop every time I say this, but you're going to love this. Let me cut this out, put it on a new page. What I'm going to do is I'm going to make a little box here. Hey, I've seen that box before. Yeah, and I'm going to put something in the box. This time I'm going to put a negative 3 in the box. I got a 5 and a negative 6 and a 7 and a negative 8 and a 10. Now, whenever I had all this, remember I did a Snoop Dogg. What did Snoop Dogg do? Drop it like it's hot. So I'm going to take this 5 and I'm going to drop it like it's hot. And then what do? We multiply diagonally and add vertically. We multiply diagonally, and we add vertically. And we multiply diagonally, and we add vertically. We multiply diagonally. 200 plus 18 times 3 is 654. So that's 650. Whoa! Oh, look at that! Oh! What did we get? We got the same thing, and we didn't have to square anything. We didn't have to cube anything. We didn't have to raise anything to the 4th power. We didn't have to subtract. Whoa, that's cool. That's out of this world. How come our teachers never showed us this in 7th grade? I would have used this all along. That's called synthetic substitution. And it's the same general idea, procedure as synthetic division. Okay? That's called synthetic substitution. So tomorrow what we're going to do is we're going to build that idea and show you how that all ties into polynomials and what the heck does that have to do with finding zeros of polynomials. Okay? So it's been real. It's been fun. I hope it's been real fun. On tomorrow I'll have a worksheet. And tomorrow we'll go back over the algorithms, the procedures, how to synthetically divide and synthetically multiply, and long divide with polynomials. So that's it.